Hey everybody, it's Dr. Gilchrist, and I'm here to show you how you can use ESCI, estimation statistics with confidence intervals, putting that onto Jamovi. So you can see here on this link, make sure that you Google Introduction to the New Statistics or Google ESCI, and you can basically find ESCI web, but for a lot of the different things that we want to do, like looking at differences between groups and thus getting a confidence interval on the difference, whether that is between groups or within groups, we're going to want to make sure that we have this in an actual software program. So you can kind of see that data analysis, you can either do this in a program that is called R. I have actually used R before. I do find that the learning curve for R, especially for undergraduates, can be a little trickier. And you can do what's called Jamovi, which is kind of like R, but it has a user interface that is a little bit easier to use. It's very drag and drop. So if you want to go ahead and actually get this for Jamovi, here are the different steps that you're going to need to do. So first of all, what you're going to need to do is download the current version of Jamovi. And it does say pick the current version, not the solid version. So we can go ahead and open that up in a new window here. So we have a version for Windows. You're going to want to make the most current option. If this, and this is clearly for Windows, so if you have a Mac, you're gonna have to get a classmate to kind of help you out with that. You can also work in the cloud, but the cloud's not really going to be very beneficial for ESCI. So make sure that you get the version that is 2.6.13 current, and then what you're gonna do, you're going to get this kind of a window. And I'll kind of zoom in so that you can see this a little bit more. So you're going to look at a modules window. You can kind of see it over here. It's a big plus sign. Make sure that you select Jamovi library. And then you're going to browse and find ESCI. ESCI, estimation statistics with confidence intervals, and you're going to click install. So when you open up Jamovi, which I'm going to go ahead and do for you right now. So I have 2.6.13. What you're going to notice is that I do actually have Jamovi here. So if you take a look here, I am now in Jamovi, and you can see that there are a variety of different things that you can do. You can do exploration, which is basic descriptive statistics. You can do t-tests. You can do ANOVA. You can do regression. You can look at frequencies. You can do a factor analysis, which we are not really going to talk about in this class. And then I also have the tab for ESCI. So we have a few different things here. So we have our describe for descriptive statistics. We can get means and medians for a single group, two groups, a paired design, and independent groups contrast, which you would want to do if you were doing something like multiple independent variables or independent variables with more than two levels. And we have a 2x2 factorial design. We also have correlational designs. We can look at one group, we can compare two groups, we can look at frequencies and proportions with a single group, two groups, or a paired design. And after we are done looking at the paired samples design, so chapter 8, we are going to move on to meta-analysis. So we can look at meta-analysis for means, differences in means, correlations, proportions, and difference in proportions. So you might be wondering a little bit, now that I have ESCI and Jamovi, how exactly do I use it? And one of the things that can be kind of tricky about programs like Jamovi or the other statistics program that I recommend, JASP, is that the way that you put your data in is really important. So I want to give you an example of how I put and format data in Jamovi so that I could do the kind of analysis that you saw on your Chapter 7 handout. So I'm going to go ahead and click Open on my data, And you can see here, I have a couple of different things. I have our Chapter 7 activity with superstition and golf data in a CSV format. So here, you can actually see a little bit of the data. So I'm going to go ahead and move this window. And I'm also going to remove my image from this so that you can actually see what's going on right now. So this is the data that I pulled up for our golf ball study. So again, this is the Damish study that gave people either a lucky golf ball or a control ball. So what you can kind of see here is we have the participant ID, we have the condition that they're in, and you do actually have to set up condition this way. So we have the control group and we have the lucky group. So if I actually look at my data, so if I click on this button right here, so we can add additional data here. We're not going to do that right now, but you'll know that you have the right idea here if you do condition, and you can see it's already figured out that it's nominal data. Remember that whether we label it control or lucky, this is nominal data. These are mutually exclusive categories. If we gave them a label, they would be arbitrary in nature. We have, and what's kind of critical here is our condition and our golf score. Now, our golf score here is mentioned as being nominal data, but you can technically treat that as continuous data. And I'm going to go ahead and do that. So if we have this data, here's how we get the data in ESCI. And I'm going to go ahead and show you how to do this type of analysis. And then I'm going to show you an analysis with whether or not people actually felt lucky. So if we look at this felt lucky average, this is a decimal data type. And there are no missing values here. So we also have felt lucky here. This is integer data. We're going to go ahead and take the average of that. So it looks like they got whether they felt lucky at the beginning versus whether they felt lucky at the end. And then they took the average of those two scores. So we're going to go ahead and take a look at those scores. So if we go into ESCI, we're going to want to look for two groups in this particular instance. We're going to go ahead and do an analysis on two different groups. So we want to compare golf score with what condition that people were actually in. So our outcome variable is going to be golf score. That's the variable that we're interested in. And now we need to have a grouping variable. And it's part of the reason why I said it was really important to keep this condition within the same column. So I'm going to go ahead and put our grouping condition as our grouping variable. And I have a 95% confidence level. We are looking at the mean difference between our groups. We are going to look at some figure options now. So you can kind of see here, we don't really need this so much. I'm going to go ahead and pick a cat's eye figure for this. So you can actually see where the values tend to be more or less likely. We also have hypothesis evaluation. So if we wanted to look at null hypothesis testing, we would want to evaluate against a null hypothesis of 0, basically being no difference between our groups. And now that we have everything we need really quick, I want to take a look at the aesthetics for our figure. So we can have, for our two groups, we can have a circle. For the difference, we can make that a triangle. So now, if we actually enter in all of those boxes, what's pretty cool is that ESCI over here on this side will be calculating the difference between our groups as we look at these two analyses. So now you actually see the data that I obtained for the handout and how I actually obtained that data. So here's a couple of different things. So here is our means and our medians between our two groups. So here we have our mean, our 95% confidence interval for each, our median, our standard deviation, the number of people in each group, and the pooled standard deviation. Variances are assumed to be equal, so we used our pooled standard deviation. And you can see here that they're pretty close to being similar. Now we can get the mean difference and the confidence interval on the difference. So again, here are the mean scores for the lucky and the control group. And here we see the mean difference, which you can see here is 0.104, and our confidence interval on the difference. Now here's our standardized mean difference. So this is our Cohen's d. And remember that you'll want to pay attention to D sub S, as that is functioning as our D unbiased. DS has been corrected for bias. Correction for bias can be important when degrees of freedom are less than 50. Now, we have 109 degrees of freedom here, so that's not something that we necessarily need to use, but you can see that they are both pretty similar here. But as we talked about yesterday, go ahead and use D unbiased, even if you do have more than 50. Here, we're testing our null hypothesis. So we have a null hypothesis that there's no difference between these two groups. So if you like null hypothesis testing, you'll want to check that box that says hypothesis evaluation. And you can see here that our null hypothesis, H of naught, is 0. Here's our 95% confidence interval, and as you can see here, ESCI now compares the confidence interval with H naught. Does it contain 0? It does. This yields a t-statistic that is 0.26. And remember what I said, if your t-statistic is less than 1, that's a really bad sign. So it tells you your t-statistic, it tells you your p-value, which here is 0.8, and it tells you your decision and your conclusion. You're going to fail to reject the null. We don't have sufficient data to determine that these two groups are different from each other and that superstition had an effect on golf performance. At an alpha of 0.05, 0 remains a plausible value. Here is our null hypothesis, and you can actually see in this instance that our confidence interval on the difference does include the null hypothesis value of no difference. So we have a good reason to believe that there's no difference between these two groups. And so if you were curious as to how I got this data for your Chapter 7 handout, now you know. So let's try this again with a different variable. So we're going to go into ESCI. I'm going to pull out my data with this little tab. I'm going to go into ESCI, and again, we're going to look at two different groups. But this time, we are going to look at the average of whether or not people felt lucky. So our outcome variable is going to be whether or not people felt lucky. And again, our grouping variable is what condition they're in. Are they in the lucky group or are they not in the lucky group? And does that affect whether or not people feel lucky? So we're going to go ahead and include hypothesis evaluation here. So for those of you who want to do a t-test for independent groups, you can absolutely do so. And we're going to do a 95% confidence interval. We're going to look at the mean difference between our two groups, and we are going to assume equal variances. So now let's go ahead and look at our data. And here it is. Let's go ahead and move this so that we can actually see our data. So now we're looking at whether or not people actually felt lucky. So you can see a couple of different things here. So first of all, you can see that the mean for our control group, whether or not they felt lucky, was about 2.05. The group that felt lucky was about 2.66. So here we have our confidence interval for the control group and whether or not they felt lucky. Here we have the confidence interval for the lucky group. Here we have the median. Here we have our standard deviation, and in this particular case, 1.154 is not 2 times larger than 0.8, so we can assume equal variances here. And here's our pooled standard deviation, which is about 1.01. The confidence interval on the difference is lucky minus control with a mean difference of 0.6 with a lower bound of 0.23 and an upper bound of 0.99. Notice that this is positive and that 0 is not included in the interval. What this means is that the lucky group probably did feel a little bit more lucky than the control group, even if their golf scores don't yield that fact. If we look at Cohen's d for the standardized mean difference, our d sub s is 0.6, which is actually considered kind of a medium-sized effect. If we look at our hypothesis evaluation, you can see our null hypothesis is that these groups won't differ in terms of whether or not they feel lucky. The 95% confidence interval on the difference is positive, and it doesn't include 0. This yields a t-statistic of 3.18, which is a solid thing. That means it's probably significantly different. The p-value is 0.002, so we're going to reject the null hypothesis. So if we actually look at our data, here's our null, here's our control group, here's our lucky group, and you can actually see there's pretty good reason to believe that the lucky group actually did feel luckier, even if their golf scores didn't actually show a difference. So they felt luckier, even though that didn't translate into a better golf score. So hopefully this helps you with looking at comparisons between 2 independent groups in ESCI. You can now add this to Jamovi, and I would encourage you to do so. It's free, it's open source, and if you have a Windows computer, you should be able to do so. So if you have any other questions, feel free to ask me. And remember to make sure that you have your data like this so that we know what condition people are in, so that we can make that our grouping variable. All right, and I will see you next time.